Airplanes, those massive metal birds soaring through the sky, seem like a marvel of engineering. But how do they actually generate lift? Let's break it down in a fun and casual way. First off, it's all about the shape of the wings. Airplane wings are designed with a special shape called an airfoil. This shape is curved on top and flatter on the bottom. When the airplane moves forward, air flows over and under the wings. The air moves faster over the top of the wing and slower underneath. This difference in speed creates lower pressure on top and higher pressure below, resulting in lift. It's like magic, but it's really just physics at work. Now, let's talk about the angle of attack. This is the angle between the wing and the oncoming air. When a pilot tilts the nose of the airplane up, the angle of attack increases. This can help generate more lift, but there's a sweet spot. Too steep an angle can cause a stall, where the airflow separates from the wing, and lift is lost. Pilots have to find that perfect balance. Next up is thrust. Airplanes need a powerful push to get off the ground, and that's where engines come in. Jet engines or propellers create thrust by pushing air backwards, which propels the airplane forward. The faster the airplane moves, the more air flows over the wings, increasing lift. It's a team effort between thrust and lift to get those big planes in the air. Now, let's not forget about the weight of the airplane. It's a crucial factor in lift generation. Airplanes are heavy, but they're designed to be as light as possible. Engineers use lightweight materials like aluminum and composites to keep the weight down. The lighter the plane, the less lift it needs to get off the ground. It's all about finding that balance between weight and lift. Another interesting aspect is the role of flaps. Flaps are movable surfaces on the wings that can be extended during takeoff and landing. When extended, they increase the wing's surface area and change the shape, allowing for greater lift at lower speeds. This is super helpful during those critical moments when the airplane is just leaving the ground or coming in for a landing. Let's also touch on the concept of lift-to-drag ratio. This is a measure of how efficiently an airplane can generate lift compared to the drag it experiences. A high lift-to-drag ratio means the airplane can glide through the air with less resistance, making it more efficient. Engineers work hard to design wings that maximize this ratio, allowing airplanes to fly farther and use less fuel. So, how do all these factors come together? Picture this. An airplane speeds down the runway, engines roaring. As it gains speed, air rushes over the wings. The shape of the wings creates that magical lift, while the thrust from the engines pushes it forward. The pilot carefully adjusts the angle of attack, finding that sweet spot to maximize lift without stalling. And just like that, the airplane lifts off the ground, defying gravity. It's fascinating to think about how all these elements work together to make flying possible, especially for those giant planes that seem too big to fly. The next time an airplane takes off, remember the incredible science behind it. Those wings, engines, and clever designs are what allow these massive machines to soar through the skies. In conclusion, airplanes generate lift through a combination of wing shape, angle of attack, thrust, and careful engineering. It's a perfect blend of physics and design that allows even the largest aircraft to take flight. So, whether it's a tiny commuter plane or a massive jumbo jet, they all rely on these principles to defy gravity and transport people around the world. Next time you see a plane in the sky, take a moment to appreciate the incredible science that makes it all possible. Flying is not just about getting from point A to point B. It's a testament to human ingenuity and the wonders of physics. So, buckle up, enjoy the ride, and marvel at the magic of flight.